Okay, so this is going to be another example of taking a derivative by using the limit definition of a derivative. And if you remember, the limit definition of a derivative is f prime of x, which is just the derivative of f of x, is equal to the limit as h goes to 0 of f of x plus h minus f of x over h. And like we said before, for this first part, whatever our f of x is, whenever we see f of x is equal to something, wherever we see an x, we will actually plug in x plus h for that x, and we'll see what we're talking about here in just a second. Okay, so we're going to do x squared, but we're going to be taking the limit definition of that derivative, so go ahead and write it out beside it so that we can see what we're doing. F prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. So like I said, wherever we see our x plus h and our x, we're just going to substitute that in. So we can write f prime of x is equal to, go ahead and write the limit as h goes to 0 of x plus h squared, since that's just getting filled in for our x right here, minus our f of x, which was just x squared, all over h. So we can go ahead and do our limit as h goes to 0 of x squared plus 2xh plus h squared, and that's what we come up with whenever we go through and actually do the distributive property or the full method just by squaring that. And you know, if you need to know how to do that, I can go ahead and write it out this way. It's going to be x plus h times x plus h. So for that we do our first. So I'll do this over here to the side. X plus h, x plus h. Alright, so whenever we multiply our x's, which is our first for the FOIL, it's going to give us x squared. And then we're going to have plus xh, which comes from multiplying our outside. So we're going to have our x and our h. And then our inside, which is going to be our h and that x. So it's going to be plus xh plus our last terms, which are h and h. So 2 h's gives us h squared. So that's where that comes from. But anyway, we are going to end up having our x squared plus, we have 2 xh's plus an h squared minus x squared all over h. And I'll go ahead and take that over to another slide. Okay, so there's where we're sitting at, and we can see that we have a positive x squared and a negative x squared, so those are going to cancel. And once that happens, we are going to have a limit of h goes to 0 of 2xh plus h squared. And technically, since that is the same thing as that over h and that over h, so if we added those two together, since we would have a common denominator, it would look like 2xh plus h squared all over h. So this is just a separate way to write it to help kind of keep things clear for you. So we can see that that h and that h will cancel, and this h will cancel out one of those h's. So then we would just be left with the limit as h goes to 0 of 2x plus 1h. So since this one is saying as h goes to 0, we technically just treat that like a 0. And so then we're just left with 2x is equal to our f prime of x. So since we had our f of x being equal to x squared, the derivative of that by using the limit definition comes out to 2x. And then once, like I said before, once we go through and actually do some of the properties of derivatives, you can actually see the shortcut, and this is the long version of figuring that out.